waking up. This is my my last lecture for this semester. Quite excited. Next lecture slot we'll have the midterm. We'll talk a little bit about that in the break, and then there will be 5 lectures of mini lectures where I get to sit in the audience and learn from you. But for today, I would like to finish this last segment I have started on deploying and scaling web services. And remember, last time what we have done is we have started from the setup that we normally have during the development of a web application when you run everything in your laptop. And we looked for a while at the issue of reducing the latency of each request. Make sure that each request returns faster. And let me just go back a little bit. One of the things we have done that is was quite significant, if you remember, we have said that we split the application and we split the actual responses to make sure that we respond very quickly to the request and only do a minimal amount of work for each request. And everything that takes a little bit longer, it gets packaged in this kind of data structure, and a description of which is put in a task queue. And then we have separate processes that go and try to process those task queues and put the results in the database. Okay, so this is part of what we've done last time. And then, so that's the first thing that you should really think of doing when you set up a web application. In fact, this is so important that unless you really have a toy application, you should consider doing this fairly early, one of the early iterations of your project. But okay, and then we discussed how this can be done, for example, in Python with Celery. But then we moved on to the next level of improving the responsiveness of our applications, and that is caching. And for caching, we have looked at browser caching and how you can take advantage of this. You are writing the server application, but you need to be aware of how the browser caching works, because you get to control it in some ways from the server. And the browser caching will help you a little bit, but it's really designed to help the particular user who sits in front of that browser. And their concern is that their experience has to be fast. Okay? What browser caching does not do, does not leverage caching among users. Okay? For example, CNN.com, each browser cache individually will make sure that the second visit by the same user to the CNN.com is fast. But CNN.com page is the same for all users, so can we take advantage of caching from one user to the next? Like if I visit the CNN.com page and somebody else comes a second later, CNN.com should not have to recompute the page, okay? So, so then we moved on, and in fact we have argued that, okay, understand the clients, but cannot rely on the clients to protect your service, whether for scalability or for security. Okay? And then towards the end of last lecture, I've introduced page-level caching, server-side page-level caching. Okay, so there's this component that I'm putting in front of the web server, and I give here several examples, but think of these as it's a proxy web server. It receives the web server request, it looks it up in the cache, and these have all of these have very complicated configuration parameters, saying if for that page the cache should be valid for 10 seconds, except if it's Tuesday, all of that stuff you can configure there, and this will respond very fast if it hits the cache. Otherwise, it will just forward the request to the web server behind it, which will forward it to the application server, which will look it up in the database, and will return it back. And on its way back, this proxy cache will store it for future use. Okay? And these are really very, very fast. Similar in kind of concept and architecture with a good web server, definitely much faster than you're ever going to write in Ruby or in Python. Okay? And remember we talked about CDN, Content Delivery Network. Do you remember what these are? I drew it on the board last time. Some form of caching, but it's a little bit different. Do you remember when I said that Microsoft, when they release software patches or new releases, they don't want everybody to come to their web servers to get it, and they contract with this company called Akamai, and there are other names. Level 3 is another one, and these companies have servers all over the world, and they impersonate various subdomains of Microsoft.com, such that when people from Asia go to download some service pack, they do write Microsoft.com, but they end up on Akamai server in Asia, where Microsoft has uploaded, in some way, has uploaded the software. So that's really caching at the edge of the network, as opposed to caching inside Microsoft's data center. Okay, but it's still the same kind of concept. And okay, so you need to figure out how to use these. And again, you're not gonna. So you'll go to work for companies that already have contracts with CDNs because those are very, very convenient. But what can you do for your particular project? Varnish and Squid. These are tools that you can install in an hour or two. You can figure out the simple configuration for them, and they'll do wonders to protect the web server from most of the accesses that can be cached. Okay. The big disadvantage to this is that they are very agnostic about what your application actually does. You can put some configuration parameters to try to make them smarter, to adapt them to what you need, but they're not going to understand the composition of your web pages. All they are going to cache is the entire response. If you're downloading a file, they're going to cache the whole file. A web page, they cache the whole web page, everything on it. Yes?
Is it possible to have not infinite, but a large amount of these caching proxies so that for one web server?
Well, you don't typically use multiple caching proxies for web server because you have to think of how this works. Okay, you will set up your networking configuration to make sure that all the requests come here. Okay, they have to sit in front. Okay, and these typically will forward the request to a web server, but sometimes to multiple web servers. You can do that. So typically, if you have one-to-many configuration, that's possible. But don't normally have multiple caching proxies. Okay? Other questions? Okay. So, by the way, we discussed about all this, and you're using all this when you deploy to Heroku. Heroku has all this for you. Okay? You don't get to configure it. It's pre-configured. It does it does a fair job for almost everybody. It doesn't do a perfect job for anybody, okay? Because it doesn't know about your application. So that's where I want to go next. And so until now, we've learned the techniques that exist, and you can invoke, but you can't really do much about them, except perhaps the task queues, which you really have to think about. Now I'm going to start talking about application level caching. This means caching that you as an application developer, you have to program in. You're going to be using tools to help you, but you have to do it. It's not going to happen for you. And that's where the cost comes for you as a developer, but also the benefit, because now you have the power to really do what you want. The example that I ended last lecture with was this kind of a shopping page. And the point here was that this is a complex page that actually you as an application developer, you understand that it has multiple components with different kind of lifetimes and freshness requirements, and therefore caching opportunities. For example, this first part here, you know that it doesn't really change. It can be cached for as long as your profile doesn't change, which may be quite rare. Here you have ads, and in fact, depending on how your website is set up, you may not control the contents of this. You may have contracted with an ad company to place ads on your page, and you don't really know when these ads need to change. That's not your control. So you're not going to be caching this, perhaps. Here you have a messages panel. This will change every time you get the message, okay? Which is probably more frequently than the profile. And here, again, something about your social network. This has its own freshness and change requirement. The reason this is important is because if you use Varnish or CDN, once you produce this page and you send it to a user, the cache will cache it exactly as is and will try to give it to other users, depending on how you configured it. But you don't have the opportunity anymore to talk to the cache and say, you know what, my profile has changed. So keep all of the others in the cache, but evict this part because I want to refresh it. So how do you do that?
Time to live.
Say it again?
Time to live.
Well, time to live is not enough because, again, the outside cache will cache everything or nothing. Because this is the response, this is one HTML that the cache sees. It's the response of your application. Okay? Your application creates this out of various templates based on different data, but at the end, produces one HTML page. So everything outside of your application, being the Varnish, being Akamai, being browser caches, all they see is one HTML page. Don't understand how you actually created it. So we have to now embed caching deep inside the process that you use to actually create these pages. And I will be describing over the next few slides one particular tool that people use a lot. It's called Memcached. D stands for daemon, as it's common in distributed systems. Memcached, really, it's a caching in memory, and memory makes it fast, as opposed to caching on disk. Varnish will use disk for caching. Memcached caches memory. So the way this works is you're going to start another process on your machine now. Okay? And if you've been keeping track, we're going to get into tens of processes pretty soon, each one helping out a little bit. And this is a process just like your database server, MySQL server, Postgres server is a process. And this process will be listening on a local port. It's typically a UDP port. And whoever wants to use the cache has to make a network connection. It's going to be a very fast network connection because it's typically on the same machine. And it's going to send commands to Memcached to say, is this in the cache, put this in the cache, delete this from the cache, those kind of commands. It's actually very simple in terms of the protocol. Conceptually, it feels like a hash table. You have a notion of keys and data. It doesn't really know what the key means and what the data means. It's all for the application to decide that. But for you as an application developer, the mental model is that you have this hash table-like thing, to which you can say, remember the data for this key, and later you can say, is this key in the cache? Now, let's see what else. I'm going to describe in more detail what the commands are and how you actually use it, but I just want to cover these high-level things. It's very, very fast, even though it's a network connection. In here, this is written very efficiently, and it's all in memory. There's no persistence, though. This is very important to remember for two reasons. First, it's in memory. If your machine loses power, it's all gone. Everything was stored in here, it's gone. Furthermore, it's a cache. It has a limited capacity. People keep putting stuff in the cache. It's going to evict stuff according to its own algorithm, stuff that hasn't been used recently. It will disappear from the cache without the application actually doing anything about that. So suddenly you may discover that the shopping cart that you'll be keeping in the cache, it's gone. Okay? So you have to use it with that mentality. So let's see how you actually use it. Do you have any questions at this architectural level first? No? Okay.
I have a question.
Yes.
How is this different from like client-side cache, browser cache?
Well, first it's in the server. This makes it very different because now, imagine okay, let me step back. For client-side caching, imagine CNN has 1 million users. Each one comes to the page once a day. Client-side caching has zero effect because each user will see I don't have cnn.com in the cache. It will go to the server. Will hit the server, each user individually. Server-side caching, when the first user wakes up in the morning and requests the front page, it's going to be stored on the server cache. When the next user comes, it will take the benefit of the caching that was done for the first user, as long as CNN says the page is the same for all users. Okay? It's very different. Caching in the server takes advantage of, you can essentially take the cache benefits across users. Caching in the browser, it's all for one browser. Okay, so you can actually install this very easily on your machine. So if you use a Homebrew on Mac, brew install Memcached, there you have it. Okay, so let's think some more about what you can cache, because with many of these techniques, I mean, you are inexperienced in web development, so you see these powerful tools, but you may not be able to understand how can they help you in your project. And that some of that will come with experience, but I'm going to try to cover some things. The idea with caching is that you have to think whatever is somewhat expensive to compute and its results have some loose freshness guarantees. And essentially, you don't have to recompute at the same time. Like CNN front page, it doesn't change in 10 seconds. Okay, so for 10 seconds, everybody should be able to get the same page without you having to recompute it. Other things, you need to change every second. Other things once a minute, other things once an hour. Okay? So whatever computation you're doing, sometimes you may even want to save database queries. So instead of sending this query to the database, I'm going to store the result in the cache such that I don't have to go to the slow database to recompute it. Or perhaps you make several queries to the database using your models, and you construct a partial view for the top part of your page. That's an HTML, it's a long string that represents an HTML that has embedded in it data that you got from the database. You can store that whole thing, pre-computed like this, such that when next somebody comes, you can just have it ready to go. Okay? Or the entire page. Essentially, at the end of your view function in your model view controller, you compute everything, you just stick it in the cache. And next time when somebody comes, if it's within whatever, 10 seconds, you just give it from the cache. Okay? Now, if all you do is caching at the entire page level, it's not worth doing using Memcached, because you put varnish in front and it's going to do this for you pretty much without warning. Memcached, it's useful once you start having this kind of fine granularity things in there. Okay, so you have to think about everything that you cache, how frequently does it change? What makes it change such that you can detect that change? Also you have to think how bad is it if somebody gets it stale? For example, for CNN page, how bad is it if I give you the page that I gave somebody else 2 seconds ago? Because the chances are that in those 2 seconds there's a new news article that came up. Okay, and the CNN designers may decide, 5, 10 seconds, it doesn't matter. Okay, I'm going to give you old news by 10 seconds, and everybody's going to be fine. But you have to make that decision. So once you decide what to cache for how long, you have to start thinking about what kind of keys you're going to use. And these are keys as in hash table keys. Memcached doesn't really put constraints. Any string you can use as a key, but there's a limit of 1K. These keys have to be less than 1K long. So let's say that in a social networking site, I have a notion of friends for users. So I may construct a key like friends:George to say, this is the key under which I'm going to store the friends of George. So here's a sequence diagram that shows how you'd use it. We have the application code. This is your Rails or Django code. We have the database, which the models talk to, and we have Memcached. And as you can see, even graphically, I put Memcached in front of the database because I'm going to use it to save traffic to the database. Database is slow, Memcached is fast. But Memcached is not guaranteed. The stuff in Memcached may have disappeared, or Memcached may be empty because you just started the machine. The database it's slow partly because it persists data to this. So let's say the application gets a request from the controller, get the friends of George. The first thing you do, before you actually go query the database, you query the cache. And so you construct this key, friends called George, and you use this get operation. This is one of the operations that Memcached has. And Memcached is going to respond pretty quickly. I don't have this in my cache, either because nobody has stored this in the cache, or because it has expired, or because it was evicted. The cache got filled up. So then your code says, oh, I don't have it. Then I go and hit the database. I run this query in the database, and let's say that this takes a little bit longer to compute, and it comes back with the result, and then immediately I stick it in the cache using the set operation. Okay? And key data. And Memcached doesn't care what's the key, what's the data, 2 strings. It's all for your application to decide. Later on, another similar request comes. Get friends of George. You construct the same key, friends George, go to the cache and say, yeah, the cache, I have it. And gives it back, and you save the request to the database. Any questions?
So the only thing that tells Memcached to go back to the database is time. If time expires, then it doesn't have to go to the database again.
So first, I just want to be a little bit precise about the wording. Memcached does not go to the database.
Okay.
Memcached, all it knows is to respond to give me the data for a key or put the data for a new key.
So
it's the application. Okay. What does it save? Yes, it's time. This is all caching. It's all about saving time.
So what if someone added a new friend on Facebook and then looked at their friends list? If that isn't in the range of time, they wouldn't see a new friend, right? But that's like the essential time to show them that they have that friend.
Yes, you have to think about all this, and we'll be doing some of these scenarios. But it's your duty as an application writer to think about what kind of staleness is acceptable, what kind of correctness you have to ensure. And I want you to be very clear. It's not a replacement for a database. Okay? This is the truth. This is the true data. This just saves access to the database. How much does it save? Well, it's actually, when you see it in action, it's amazing. It just feels like your website has come to life. For example, each of these lines is a scenario that you may want to save. Let's say you have a simple SQL query, and it's a query that the database hasn't cached, because the database itself has a cache. It caches the last few queries you've done. Okay, you can do about 6,000 a second on this on MySQL, if it's a really simple query. If the query is in cache, you can do 10,000 in a second. So I'm reporting speed in terms of queries per second. Okay, so
does it include transportation or not?
It includes the network communication. Yes, but this is network communication on the local machine. That's actually very fast. It's just some essentially memory transfers. Okay, no. So this is query in the cache. Sorry. This is query not in the cache. Suddenly, you can't do as much. If you start getting into complex queries, with a lot of where clauses, maybe some of them are indexed, some not, you get into hundreds of milliseconds response time, which gives you about 10 per second. And when I started using Memcached for my application, I was actually running several of these to construct the web page. Okay. To the point where it was starting to get like 5 seconds to construct the page. So you go 1, 2, 3, 4, 5, and the page appears. And it was because I had to go to the database. But then once I put it into Memcached, it's instantaneous. Okay? Because notice the cache doesn't care about how complex the computation is. So you have to be smart. For something like this, if your application is really a toy, all it does is simple queries, you may not see a difference from Memcached. But once you start doing complex stuff, that's when you see. Okay, questions? Yes.
When you add Memcached, you have to plan ahead, really, or you can just add it like later on when you already have your application built. Something you can add easily, in a more progressive stage of your development.
That's a very good question. When do you have to go to this technique? So rule number 1, Any of these optimizations you should not do until you know that you need them, which kind of says you don't do it ahead of time. You first measure and you see what is actually slow. And then you go to this optimization. Now, that being said, if you're starting from the onset to build something like Facebook, you know you're going to need caching. So it probably pays to think ahead of it. But to answer your second part of the question, this is something you can add later to it. And it's easy to add at the level of a view. In fact, in Rails and Django, you just put a little marker, say, this is a cached view for 10 seconds. That's going to do all for you. Okay? Whenever it sees that URL coming, it's going to look at the cache. If not, invokes the view, then sticks the result in the cache for 10 seconds. But all you get is whole page granularity caching at the view level. If you want to do more sophisticated stuff, you probably, like at the database query level, caching, you may have to go inside and make changes to your application. But certainly doable after the fact. Okay, so now here's a complicated complication that comes up. And this is very common with all of these optimizations. You have to think of all the possible scenarios, and sometimes it might turn out to be not optimizations, but actually slowdowns. So this is, I'll walk through this scenario, and it's called the thundering herd. It has a very colorful name, and you'll see why. So essentially what you have done, you have set up Memcached to cache the result of querying the database. And let's say that you're going to be caching using this key friends colon George. And the first time somebody comes to ask for George's friends, you get the cache miss from Memcached, which makes you go to the database to query to find the actual friends of George. And then let's say that the database takes about 2 seconds to do its computation. Let's say that this is a more complex query that you want to cache. So 2 seconds later, the response comes back from the database and you stick it in the cache. You do this because next time somebody calls get friends of George, you go to the cache, you get the cache hit, and immediately you can return. So you see the initial request took 2 seconds, next request takes 10 milliseconds or 1 millisecond. Okay, this is what caches give you. However, you think, okay, well, I'm okay to storing this in the cache for 1 hour. This probably means that you know the data will not change within an hour, or you think 1 hour is an acceptable staleness for this particular application. Okay? If somebody gets George's friends as of an hour ago, it's good enough for this particular application. So when you put it in the cache, and this is a change compared to the previous slide, you add this expires parameter. This is a very important feature of Memcached. You can tell it, stick this in the cache, but 1 hour from now, just delete it silently without me having to tell you. This is good because you know that 1 hour later, when somebody comes, it's going to miss in the cache. So this is 1 hour later. We'll force you to go to the database, another 2 seconds of computation, and you come and then store it in the cache. Okay? And you think you are done because you are saving these 2 seconds because now it's going to be 1 millisecond instead of 2 seconds, most of the requests, and you have implemented the freshness requirement of 1 hour. Okay, what actually happens if you're unlucky, your site starts to become really popular. I shouldn't say unlucky. If your site starts to become really popular, and you think of yourself as lucky, what happens is you get lots of these requests for George's friends, okay? So George is here very popular, but let's say this is CNN homepage. It's quite reasonable. You're going to get lots of requests. And the good thing is that for this 1 hour, all requests will be served in 1 millisecond. So you can really deal with a lot of traffic. But as you come to the end of the 1 hour, Memcached is going to throw, it's going to expire the entry from the cache. Requests keep coming in at the same rate because they don't know that the hour expired. And each one will find the friends missing from the cache, and each one will start going to the database. And suddenly, your database, after being quiet, completely quiet for 1 hour, now it experiences huge load. And this load can easily get you by surprise. Because typically you put Memcached in place when the load is not too high, and suddenly the load to your database decreases. The database becomes so quiet. It's so nice to monitor and see, well, nothing's happening. My database is nice. But it's only quiet because Memcached is taking the brunt of the load. And when Memcached stops doing that, you'll have this kind of thundering herd, it's called, when you get a lot of requests coming directly to your database, hitting you where it's actually the whole application is very sensitive. Each one is going to take 2 seconds, so you can get many requests in those 2 seconds. Okay? And that's when your system collapses. Because while Memcached was fine dealing with thousands of requests a second, the database can't. So in some way, your optimization misfired. It worked for a while, and then when it stopped working, it kind of the whole traffic ends up hitting your database. I'll talk some more about what to do in this case, but do you have any questions about this scenario?
So the server handles query like one after another. Why suddenly the server starts to handle all the queries at the same time? So we have a queue and
the queries, well, you have 1 million users. There's some news on CNN. There's 1 million users who come to CNN. You have to handle them.
I thought we have a queue to store all these queries, and we
Cache.
No, well, we don't have a queue. We try to, because the whole point, you want to answer everything quickly, right? So you don't want a queue. You want to answer everybody quickly. That's why we put the cache so that all answers come back quickly. And this is not something you can easily control. Queuing is a solution. At this point, maybe the system can detect this situation and starts doing some queuing here. That's not a technique that I'm not going to be talking about, but it's a possibility. It's not easy to do that. The solution I'm going to describe is a slight variation in how you use Memcached. But I'm going to bring back our friend, the deferred task queues. Remember the deferred task queues that we said the web server, whenever it gets something that takes longer to do, it will defer it in a task. Okay, so here's how it goes now. The beginning is the same. You get the request, misses the cache, you go to the database, takes 2 seconds to compute, you get the result, and you stick it in the cache. Okay, so this is request number 1. It's warming up the cache. But the moment you put this in the cache with a 1-hour expiration, you already know that you're exposed to a thundering herd in 1 hour when this is going to expire. So you schedule warming up or refreshing the cache in 59 minutes. Okay, and you can use the deferred task queues for this. So deferred task queues can be used for periodic tasks in addition to deferring work on web requests. And for 59 minutes, everything is fine because stuff is in the cache. In fact, for 1 hour, everything is fine. But 1 minute before that hour expires, that is in 59 minutes, this deferred task kicks up its computation. And we know it takes about 2 seconds to recompute the data that everybody wants. So that's why we gave ourselves a whole minute before the expiration. So the deferred tasks, notice the actual query to the database comes from here, not from the application. The application is still hitting Memcached, which can do very fast. But this one, there's only one of it. So very quietly, it goes to the database. The database takes 2 seconds to compute its data, and then the same application sticks it back in the cache. Such that when the 1 hour, and when you do this, it kind of resets the expiration time. So truly, Memcached never gets to expire by itself. It's all updated under the control of either the application or the deferred task. And then once you do this, you schedule another refresh in 59 minutes. And this should keep going nicely like this. Any questions?
So how would you ever remove the friend list from the cache if the deferred task is the one that keeps on refreshing the Memcached?
Okay, so the question is, how do you ever remove it from the cache? Because there's this guy here every 59 minutes we'll put it back in the cache. So first you have to think, why do you have to remove it? And I'll tell you in a bit how you may even remove it. But before, it's more important to realize that you may not need to remove it. Keep in mind that this deferred task would refresh it with up-to-date content every hour. So it's only as old as 1 hour old, at most, if you're unlucky. Okay? And let's say that the architect for this has decided that this is an acceptable kind of a parameter for your application. So it's not really as stale. Furthermore, Memcached, keep in mind that it's very good at managing its space. So you shouldn't worry about overloading Memcached because it's going to kick stuff out of the cache. It's going to evict old stuff from the cache. It's going to keep track what's the most recently used element and throw everything out. Okay, so you don't often have to remove stuff from the cache, but I'll tell you how when you actually do need. Yes.
So just to clarify, you said that Memcached is the one that actually will delete stuff that's in the cache. You don't have to build that functionality yourself. Like when it expires.
Indeed, there's two ways for deleting, actually multiple ways for deleting stuff in the cache. The most common and the most reliable is to tell Memcached to do it by itself. Let me say one more thing that I kind of glossed over before. Memcached is built to be fast, and it cuts corners to get to be fast. And one way it cuts corners is that it does not guarantee its operations. So some of these messages Memcached set may actually get lost, and there's no guarantee. And because of this, you will see in a bit that deleting stuff from the cache, it's actually a tricky operation.
Because of the UDP you mentioned, or not related to that?
Because of all sorts of things. It's built it doesn't take a lot of care to fail in a safe way. Because you say, well, you have the database for that. And I don't want to be as slow as the database. So I'm going to just cut corners, and 99.99% of the time I'm going to work fast. But in that, what's left, I'm just going to screw up badly and just recover. So because of this, this is very powerful, because if this message got into the server, to Memcached, Memcached knows it has to delete it. It does not, you don't need to be able to contact it again 1 hour later. So it's very powerful. And again, if the get doesn't get to the server, it's as if you don't have it in the cache. You have to be ready for that anyway, right? So when you use Memcached, you really have to use it for what it's good at, but don't put too much correctness reliance on it. Okay, so again, in this case, the herd will always hit the cache. In my applications, I actually have periodic tasks like this that keep the caches warm. Because I said I have this big page that takes 5 seconds to display. And I don't want even my first user, when they come in the morning, to take 5 seconds. It's just bad. So I have a periodic task that once in a while refreshes and puts in the cache the front page. So everybody, when they hit the site, they get the page very fast. It might have been computed a minute ago by this periodic task. Okay? So it's very, very useful. So let's say, so 15 more minutes or so. Really, there's a lot of stuff. I think now, having prepared these 2 lectures, I could teach a semester of deploying and monitoring and self-healing for these web services. And it's very hard, though, to do it in a university setting. It's very hard for you to appreciate it because you're now so focused on building functionality in your app. It's hard for you to imagine a day when your app is wildly popular and you move on to another project. And this thing has to keep going by itself. And if something crashes, it comes back up by itself and all that stuff. But that's really what it takes to do a serious job. And especially if you want to build an app for others to use, you'll have to give them a good experience. So much of this stuff. I have more slides that I can possibly cover in the remaining 15 minutes, so I'm going to skip over some. And
is it important we go over those before Thursday?
No. So the stuff from here on is not probably most likely going to be on the the midterm. But really, I mean, I don't like to think that like that. So this is all cool stuff. It's not going to take you much to follow. So what do you do when you have to update stuff from Memcached? Okay, the most direct way is you put stuff in the cache with a set. Set, give the key, and then some data, a big string, and it's going to store it there. And you can set the expiration times. It's a very good idea to put the expiration times on it, because in a very complex system, it is possible that one of these Memcached servers is being accessed by some of your workers, and you lose access temporarily to it. You cannot tell it, delete stuff or whatever. So it's good to know that whatever you put in there goes away by itself, so it won't get too stale. And it's not only easy, it's also the safest way to delete stuff. There's also a delete operation. It's not used as much. Most often people kind of update the key rather than delete it. And one complication is that Memcached may not guarantee its operations. You may think, how could somebody build a system and not guarantee that it works? But imagine when you have thousands of these across the world. Now, network connections get up and down at various times, and Memcached is not really built to be reliable in face of all of these kind of network issues. So some of your deletes may not get to all of the caches. Okay, so there are some limitations. Some of them will bite you in the middle of the night. You'll see, because that's when all these fun things happen. This first three here, or the first two, you really have to be ready for. Data can be evicted from the cache. In fact, it will be evicted. Eventually, if you keep putting stuff in the cache, you'll fill it up, so you'll have to drop something from it. So you have to write the application expecting that sometimes stuff is not going to be in the cache. It's a cache, right? It's not a database. Second, the server may restart, and then everything gets lost. And servers do restart. You bring up a new machine, you shut down the machine to upgrade the software. It will happen. It should really behave to you as if suddenly the stuff got evicted from the cache. So you recompute it, you put it back. What's perhaps harder to think about is that set or delete operations may get lost. It may not get to all of the servers. This is the one that's particularly annoying. There's limits on the sizes of keys and data. So data for each entry must be less than 1 megabyte. And if you start putting big whole web pages in there or results of queries, they are going to suddenly go over the 1 megabyte limit without you noticing. Okay? And you'll get these errors that you've never seen in testing. So this is actually very, very annoying. The other thing is Memcached, unlike a database, it cannot enumerate the keys. You can tell it, is this key in? Give me the data for this key. But you can say, give me all the keys that have friends, that start with friends, or all the keys whatsoever. Because that is an expensive operation, and they don't want to implement anything like that. So how do you actually deal when you have to update multiple keys at once? And there is a very important trick that I want to kind of communicate to you. So assume that you have several keys for stuff related to George's page, friends, posts, photos, and there are times then when something changes for George's profile that you need to kind of invalidate all these. And we know that we cannot ask Memcached to enumerate keys that match George. And even deleting keys explicitly, it's a little bit iffy because the delete message may get lost. Each of these has its own expires for an hour, let's say, but you don't want to wait for an hour to kick this stuff out of the cache. So what can you do? And there's a very important trick. It's called key versioning. You construct the keys to contain not only the part that you think it's important, but also a version number. So this says, these are the friends for George under the version 123 of the, let's say, profile or preferences for George. And the cool thing is that as long as you use this key, you're going to get the data. But then at some point, you may want to move to the next version. And then very transparently, you're essentially ignoring all of the other keys. It's as if they are gone. Let me explain this in more detail. So this is the application Memcached in the database. When you get the request for George's friends, first you go to the database. This is a different scenario. You go to the database for a very simple answer. What is the current version for George? And it gives you 123. This means that all of the keys, photos, friends, posts for George, sit under version 123. You use this to construct the key for Memcached. And now you say Memcached, give me friends George version 123. It says here it is. And at some point, you want to update George. And by the way, these things exist in Memcached with a very long expiration time. But at some point, you want to ignore them, start ignoring them. And you do that by simply telling the database, move to the next version for George. Once you do this, whenever anybody comes and asks the database, what is the version for George, gets 124. And now they go to Memcached to ask for version 124 of George's friends, and you get a cache miss. Version 123 is still in the cache. You haven't deleted it. All you do is you ignore it from now on because you'll be looking for version 124. That's a cache miss. It forces you to go to the database to get the friends, put it in the cache, and from now on, everything will be version 124 until a day later when something again happens to George's profile and you bump to the next version. Okay? So this is not deleting from the cache. The stuff is still there, but the way you construct the keys, you move on, essentially leave that stuff behind.
How does the application knows which version to ask for?
Well, the versions are stored in the database.
But in the future, like, we move to 124, how the application knows now when someone makes a request, I want to ask for 124. Like how
you go to the database and say, what is the current version for George?
Okay.
So you store in the database the current version of the data in the cache.
So it doesn't require you to make a lot of requests to the database to ensure what version you want.
Very good observation. Aren't we negating all the advantages of Memcached by going to the database before going to the cache? Because, right, we were going to the cache to avoid going to the database, but now we force a request to the database. Well, it doesn't, turns out, because these are very cheap queries. Very small data, it's a little number that comes back, so the transfer is small. This is a small table, typically the version table, and it's going to be the database cache. So this is going to be a very fast request, but it's nevertheless a database request. This, presumably, it's a complex computation, complex query that you want to cache. So you have to think about all these things. Other questions? Okay. Key versioning, this has disadvantages as well. I do want to spend a few minutes on another dimension of deploying web services. Really, again, this should take several lectures, but I'm just going to skim it in a few minutes. So far, what we have done, we have worked on the issue of latency. Make sure we respond very quickly to the clients. And to do this, we have taken advantage of browser caching. We have put this varnish cache to do page-level caching in front of our server. We have put this real web server and to make sure it can access very fast stuff directly from the disk, like static files, JavaScript, CSS. We have split the application server into an application and a task worker to make sure that the application only does the quick computation for response. Everything else gets deferred and processed later. We have put Memcached to allow the application to kind of save some requests to the database. And all this, for one user, you should have improved the experience. But the question is, and by the way, this is complicated enough, but it's not enough for you to really be able to make a profit typically out of a web application, because you need lots of happy users, not just one. But once you got one happy, you are in a good position to increase the number of users. And this is really cool stuff. I'm sorry, we're going to run out of time. This is a little diagram of how you should think about making money with a web application. So let's say this is your revenue. For every user, every request, let's say you make $1,000 of a dollar. This is called the $1 CPM, cost per 1,000 ad impressions. So more users, more revenue. Then you have to subtract the cost. Well, you have some salaries and other fixed costs. This gives you a break-even point of here. This is the number of requests per day to make up the salaries that you're paying. If you can support more requests per day, you make a profit. Everything from here on is profit. Well, these are just the fixed costs. Typically, every request uses hardware, electricity, all that. So you have some variable costs as well. The happy situation is when you have linear variable costs. Every request costs a little bit, and if you have 1 million of those, they just cost 1 million times more. So linear scaling. This is what you get for a good design. And hopefully the scale, hopefully your business development people will get the slope of this curve higher, will sell expensively, and your engineering will get the slope of this line lower, such that they actually cross over. This is your break-even point. Salaries for variable costs for this many requests a day, and that's a profit. If you go above it, the difference between these two lines is your company profit. But this is only if you do a good job in engineering. A bad job in engineering results in this curve. The more people come to your site, the slower things start to get, or the more machines you have to put in, the more electricity you have to consume. So this is you do if you need to do very complex queries that require coordination, database joins. Okay. However, your engineering team can deliver you better than linear scalability. This seems strange. How could I actually reduce the cost by increasing the request? Well, I'm not quite saying that. I'm saying that the cost of every additional request gets lower. And there are techniques like caching that do this. Because the first request, you pay a cost, but you cache it. Next request for the same data, it's a smaller cost. So if you do this, you increase your profit, because now the profit is the difference between the white line and the green. Okay? So how do you do this actually? So I have here some data to just give you an idea of what the big companies that you know about are doing. But just imagine, these are all numbers a second. On YouTube, you download 2,000 hour worth video hours in 1 second. Imagine the scale. So let me just skip over this. The big solution here, as you might have guessed, is to start replicating your architecture. Instead of one application server, have several application servers. Instead of one task server, have several task servers. Okay. And the cool thing is that the moment you have actually started using a real web server with a real application server like UWSGI for Python, these have built-in configuration parameters for spreading out the work. Nginx is actually very good at load balancing. UWSGI is very good at managing these. You just set up how many of these you have. It's a little bit like in Heroku, where you configure the number of dynos. You just change the number, they'll immediately spin out several, and they'll build logic in here to kind of send work to different workers. Okay, so this is the first step that you do, and very commonly you will have 8 or 10 of these. You have another 8 or 10 of these. But if you have an application where there's a lot of work here but not as much here, you may have more here, fewer here. Okay. And the moment you start doing this, your application, notice how many copies of your application you have. These are all in different processes. So remember when at the beginning of the semester we said we cannot use global variables to store state? Global variables only exist in one process at a time. So because you want to be able to split your application to many processes, we are using the database. Even for a hello world, there's 1, 2 numbers, you use a database because it's the only thing that can give you a uniform access to view of your data from multiple processes. Okay. So let me. So I have a few more slides along the same lines of load balancing, but I will stop here.